All right, so did you start it?
Yeah, but what I did was, I took the cosine, I like split the one on the right.
So you can't split unless the numerator's in the one with the plus. So if this was reversed, now I could split it in a cosine over cosine plus sine over cosine. But because the denominator has the sum, you can't split it. You would have had to find at least common denominator. So I would have said work the left side. So like 1 over 1 plus sine x cosine x. And I'm not saying this is the right way to do it, but let's just try it. And then, or the easiest way. And then I would change the denominator so they have the same. So this would be cosine x over cosine x. And I'd get 1 over cosine x plus sine x all over cosine x. And then it's a fraction within a fraction. So I want to flip it. So keep the 1, change the division to multiplication, flip the denominator, which becomes cosine x over cosine x plus sine x. And then the 1 times just becomes the right side. Yeah. Do the right side?
Yeah,
You can't really.
no,
Did you make it? Unless you make them their reciprocal functions.
I did it, but I know what I wrote down.
Yeah, like you'd really have to like make it so that it's 1 over secant. In order to get from a product to from a sum to a single term, you'd have to. And then this would be cosecant x plus secant x over secant x cosecant x. That's the denominator, so it's still under cosine. And then you'd have to make cosine like 1 over secant x. Flip it. And then these cancel. And then I think you have to do it again. You'd have to give it a like denominator again. So cosine x plus sine x over sine cosine. And that's the denominator. So then you'd have to take this, keep, change, flip. Cancel cosine x. Did I work backwards and get the same thing? What am I doing? No, and then that. I brought it right back to the beginning. Don't do what I just did. Yep. I mean, good, because I like literally made it something different and then brought it back to what it was in the beginning, and that's not helpful in any way, shape, or form because you were trying to get the other side. I think the answer to your question is don't do that. Yeah? All right, so for number 7, first of all, you've got like cosecant and secant. They're both squared, so I would have gone to like your 1 plus tangent squared equals secant squared, like to see if I could mess with that a little bit, and you can't. Like there's none have both cosecant and secant, right? So what can you do to like combine them, let's say?
Can you take off the secant with the secant?
Can you cancel like that?
Yeah.
Not unless you can cancel into both. So, but what you can do, and this is not the only way, but I can make that 1 over sine squared x plus 1 over cosine squared x, right? Keep the secant in the bottom. And then you can combine them into one by giving them a like denominator. So cosine squared x plus, and then this would have to be times sine squared x. And I end up with cosine squared plus sine squared over sine squared times cosine squared, still all over secant. So then what's cosine squared plus sine squared? 1. So I get 1 over sine squared x cosine squared x, and all of that goes over secant x. So now if I wanted to, because obviously I don't want the fraction within the fraction on the right-hand side, there's only one fraction. If I wanted to bring secant to the top, what does it become? And then you can cancel one of these cosines out, and I end up with 1 over sine squared x cosine x equals, and there's the other side.
So the reason you can cancel out that is because there's no addition sign in the
Right. Yep.
Is there another way you could do this?
I'm sure there is.
Could you like flip everything? Could you like when you start?
So you can't move the sum to the bottom by making it its reciprocals. Is that what you mean? It has to be either a single term or part of a product. So I can move, God bless you, I can move these up and make those the reciprocals, but I can't move anything that's got a plus or minus sign in between them.
Are you allowed to change that sign?
Sure. Yeah. So you made it 1 over sine squared plus 1 over cosine squared? No, actually, no. It would be 1 over sine squared times 1 over cosine. And then did you make them the reciprocals?
I did cosecant squared x over secant x plus secant squared x.
Oh, this side.
Yeah.
Yeah, sorry. Cosecant squared x. Oh, my word. I'm forgetting letters. Cosecant squared x over, they both get the secant, right? Plus secant squared x over secant.
Yeah, are you allowed to do that?
Sure. And then you can cancel one of these,
Mm-hmm.
right? And then what'd you do on the left?
And then
Those you can flip-flop. So you can bring secant to the top as cosine,
yeah.
and you could bring cosecant to the top as it would be sine squared.
And then I also switched. I made it 1 over cosine x.
This one?
Yeah. And then I made them so that this.
I don't know why I keep putting plus. This is multiplication, multiplication, multiplication. Sorry.
Wait, no, that is. I thought it is plus.
Oh,
It's from the other side. So it's plus. Yeah.
thank you. Oh, no, here.
And then I gave them.
Not this. And then what?
Like
Like denominator, so times cosine here. Times sine squared here. So cosine squared plus sine squared over sine squared cosine. And then made the top one.
Yeah.
That works. Mm-hmm.
Shouldn't you just like take the secant out and then put it to the top of the cosine versus the cosecant?
Move this up, you're saying. Make that cosine.
Yeah, and then just flip like that was the top one into the bottom.
You can't move these to the bottom because it's and making them the reciprocal. It only works if they're individual or if it's a product. So you can't move a sum or difference. Yeah. So 9 says negative cosecant x squared x times cosine squared x equals 1 minus cosecant squared x. So did you start it?
Yeah, I did 1 over negative sine squared x times cosine squared x. And then I got cosine squared x over sine x. Sine 2x.
Negative sign, right? Yeah.
2x. And then there, like, I was confused, like, because then for the other side, I flipped it over to be 1 minus, and then 1 over sine, and then I solved it, and I got cosine squared x over sine 2x. But then I didn't know how, like, it matched with the other side since the sine is equal.
Okay. So what I would have said that this should lead you to your Pythagorean. Not that you couldn't get there from there, but I think it's easier. That leads you to like a 1 and a squared or 2 squareds that are sum or difference, like immediately go to your Pythagorean identities. And so cotangent squared plus 1 equals cosecant squared. So if I got 1 minus cosecant, that means this one came over here. 1 minus cosecant squared x, which means the cotangent had to go to the other side, negative cotangent squared x. So that's an opportunity to change that side. And then cosine over sine is cotangent. So negative cotangent squared x would equal negative cotangent squared x. So I would have changed both. But you could have also said, okay, this is negative cotangent squared x. So then go here and say, what would negative cotangent squared x be? And it could have been 1 minus cosecant squared x equals 1 minus cosecant squared x. God bless you. Any other questions before we get into the class kick? Yeah.
Can you do number 4?
Mm-hmm.
Kinda, yeah.
What'd you do?
I did
Was it like a moment like I did?
Yeah.
All right, so I probably would have, because you can do either this side or this side with your Pythagorean identity, 1 plus cotangent squared equals cosecant squared. So if I move this to here, this would have to go there. That's -1. And then that's negative secant x. And then on the right-hand side, you could do the same thing because 1 plus, or tan squared plus 1 plus tan squared equals secant squared. So if now this is on that side, the 1 goes to the other side, that is also -1 over cosine. And then -1 over cosine is negative secant. You're welcome.
For that one's extension, can you also get -1 over cosine and just flip?
Yeah. Mm-hmm. As long as your last step is literally that the left side equals the right side, you're verified. I would say if this was, which it couldn't because you had to work both sides, but let's just say if it was only one-sided, if this was on your simplify and you had an answer that was 1 over cosine, I would say take it to the next step to get, like if you can get it down to one term, that is as simplified as it gets. So if it was just a simplify, you would want to go to the next step. But if it's a verify, it doesn't matter.
Are there questions that say like factor instead of simplified?
There are some that are factors.
What's the difference with the answer for that?
It's just like the factored form of it. So there's actually some in the class cake you're going to see right now. Yeah.